In this video, we're going to go over some of the questions from lesson 3.7. So in this lesson, you were introduced to the idea of a proportion. So proportion is just a statement that says that two ratios are equal to each other. So you are setting up a proportion and testing whether it is a proportion by cross multiplying. So this is the proportion that you could have set up in the example for number 2 with the logo and the billboard. So if you multiply the cross products here, 2.25 times 6, they should be equal. So that should be equal to 4 times 3.375. And there's lots of different ways that you can set up a proportion by just kind of moving things around. But what's important to remember is that the values in each fraction have to have a relationship, the values in the numerator have to have a relationship, and the values in the denominator have to have a relationship. So in this example, maybe you set them up so that the first ratio are both from the same object. So this could be from the original logo. The side is from the billboard. The values on top are both the widths of the object, and the values on the bottom are both the lengths. The units don't have to necessarily match all around, but the units should kind of agree with the relationships that you have. So there are a couple of ways that you could set up that proportion. They should do another way in number 4. No matter how you set it up, the missing piece is always the same. So I'm going to talk about questions 5, 6, and 7 in this video, starting with number 5. For 5 and 6, both of the proportions were already set up for you. So all you need to do is go ahead and find the cross products and then solve that resulting equation. So I'm finding the cross product of 12.7 times 3 and setting that equal to 0.2 times x. When you have a number and a variable, you can just write them next to each other with no symbol in between. Usually we put the number first. So then I'll go ahead and multiply 12.7 times 3, which gives me 38.1. And still using the same principle, so this is a multiplication. I want to undo that by dividing. Do the same thing on the other side. So that means that the value for x is 190.5. We're told to round to the nearest tenth, but that comes out to be to the nearest tenth exactly, so we don't need to round. For number 6, again, it's set up for us, so I'm finding the cross products. 8,500 times 5 equals 4,200 times x. I'll multiply on the left-hand side. And that gives me 42,500 equals 42,000x. I'm looking for x. I'm going to divide by the coefficient for x, which is 42,000 or 4,200, the value that we see right in front of x. So I'm going to divide by that on both sides. And when I do divide by both sides by 4,200, I get 10.1 is approximately equal to x. And that's rounded to the nearest tenth. All right, for question 7, you were given a word problem to kind of decipher, and you have to set up the proportion. This is a skill that you should be able to do. So it reads, many small engines for saws, motorcycles, and utility tractors require a mixture of oil and gas. If an engine requires 20 ounces of oil for 5 ounces of gas, how much oil would be needed for 8 gallons of gas? Now, there's more than one way that you can set up this proportion. The way that I thought about it was to think about the first relationship for one particular engine, the 20 ounces of oil to the 5 gallons of gas, and I put that in a ratio. And then I set that equal to another ratio where I had the amount of oil, the ounces for oil in the numerator, which is missing, compared to the 8 gallons of gas. All right, so here's one way you can set this up as I described. So in the first ratio, again, I have the relationship between the ounces of oil to the gallons of gas. I'm just going to write that to remind myself that the two fractions I write, I want the oil on top, the gas on the bottom. And for the first engine, 20 ounces of oil is mixed with 5 gallons of gas. I'm putting the units just to remind myself of what goes where. I really don't need to have them. The second ratio, we're looking for the amount of ounces, and that's to 8 gallons of gas. So we'll go ahead and cross multiply 20 times 8, and then 5 times x. 20 times 8 is 160, which equals 5x. Divide both sides by 5. And I have 32 equals x, which means I need 32 ounces of oil to match with that amount of gas. Let me go back to that here. And what you should, always think about is reasonableness. Does this answer make sense? So if we have 20 ounces for 5 gallons, if we have more gallons of gas, we're going to need more ounces. So that answer should reflect that. But it shouldn't be too much more where it seems absurd that it wouldn't make sense.